So this is an example of, so you already saw what is a linear regression. The last example was a example of linear regression, right? And now you will see like what is a logistic regression. So I guess I have covered this example. Like I have talked about this example earlier on, like um, classifying an email as spam. You have thousands of emails, you want to classify them as spam, and you want to know like whether that email is spam or not. And yeah, so that is basically the algorithm where, you know, uh, where you need logistic regression. Like, but the question is again, like, how do you do it, right? So again, I'll go back to my whiteboard. So before that, I just want to explain one thing. Okay. So in this picture, if you see, so the hollow circles that you see are basically not spam, whereas the uh, you know solid circles are basically spam. Okay. So now, what is your model? Your model is classifying whatever is within this region, with this circular region. The model is classifying everything as spam. Okay. So in this region, if you see this green region, these are the examples which are solid circles. That means they are actually spam, and your model is also classifying them as spam. So these are called true positives, because they are truly spam. Sorry, because they are like positive examples, and your model is characterizing them as true. Okay. Whereas in the this red region, these are called false positives because they are positive examples, like positive, not positive examples. They are like being positively classified as spam, but they are actually false. They are actually not spam. You see, these are hollow circles, so they are not spam, but they are falsely classified as spam. So that means they are called false positives, right? Whereas in this region, these are spam, but not classified as spam. So they are called, um, you know, uh, false negatives. Okay. And on the other hand, sorry, false positives. Sorry, yeah. So they're truly they are. Wait a minute. Am I mistaking something? Okay, so the green region is the true positives. The red region is the um, false positives, and this region is the false negatives, and this region is the true negatives, right? Okay. So again, if you see from this chart, okay, so the true class is positive. So by positive I mean spam. So if they are truly spam and your predicted class, if you are classifying as spam, then it is true positive. So the green region. On the other hand, if the true class is negative, but you are still classifying them as positive, if you are still classifying them as spam, even though they are not spam, then it is false positive. So the red region. So again, if the true class is positive, that is truly they are spam, and you're classifying them as not spam. So this region, the dark gray shaded region, that are false negatives. Whereas in the light gray shaded region, they are not spams, but and you are also not classifying them as spam, so they are true negatives, right? So this way, this graph is a way to think about it. I think otherwise it's very confusing actually. But yeah, this is how it works. Someone has talked about definition of recall and precision. Yeah, I'll come to that in a moment. Before that, I just want to explain like how do I mean, I'll not go into detail, but you know, just to see like uh, how you classify them as spam or not. Yeah, on which factors we can determine the email as spam or not. Yeah, I'll just come to that. Right. So let me see. Okay, I think it is visible now. Okay, so yeah, you can see it here, right? Mhm. Okay. Okay, so let's say, as I was mentioning earlier, like at the beginning, so if you have some on what factors we can determine spam. So, uh, I mean, the modern day spam algorithms that we have is that, so if you're, so you might see that, when you receive a lot of mails, once you classify one mail as spam, you won't get similar mails next time, right? So your machine trains its model based on, so you are giving the tag to the model. You are saying that, okay, this email is tagged as one, should be tagged as one. So that's where the machine gets the output, right? The output Y parameter. That's where it gets it. And whereas how it gets the input parameters. So the machine looks for words in that email. So let's say you classify one email as spam, which says money, money, let's say 5 times money. Okay. And you classify this email as spam. So now the machine learns from this email. So this is tagged as one. Whereas another email which is sent by some of your friend, maybe he wants to meet you for lunch, this is not tagged as spam. So this is the Y variable, the output parameter, right? Whereas this is the X variables, the input parameters that you have, right? So the machine has both the X and the Y variables. Now it builds a model based on, so there are like thousands of emails, so on, right? And all are tagged as such. And the machine uses uh, well, there are a lot of complicated steps in between, like how to convert words into numbers and so on. I'll not go into the detail of those, but this is basically the outline which the machine does. It looks into each of the emails and it sees that whether how many times money has, like the word money has in this email, and if it has some you know let's say money was mentioned twice in the email, it will have a certain probability of getting into spam, and it exceeds certain threshold, then the machine automatically puts it into spam. So that's how does it. And again, as someone mentioned, like what is the difference between uh, logistic regression and linear regression. In linear regression, you saw that your all the values it was taking was a continuous values, whereas the output values. Whereas in this case, the output values are discrete values. Like it can be spam or not spam. It can be one or zero. Like right, it cannot be like 100. Right? What does 100 mean? It means nothing. So it can either be yes or no, yes spam, no spam, one or zero, positive, negative, whatever you call it. Right? It can only take binary values. So that is the difference between basically logistic and linear regression. Rest of the method, uh, is same. I would say in both the processes. So, like as we saw in linear regression, what we do is we calculate an error function. In this case, also we calculate an error function. The error function is no longer the least square. We do something called the entropy function. I think you might have heard, or maybe you will hear it when the professor teaches about logistic regression. And then we used gradient descent to, get into the least error, the least entropy solution. And from there, we can get the parameters, right? So let's say your model has trained and it has trained like spam equals to, you know, if money is mentioned like one time, it will get a weight of let's say zero point 0.5, and if lunch is mentioned one time, it will get a weight of 0.01 because it has less weight, less probability of becoming a spam, and so on. This is a very crude model. Okay, this is not exactly how it works, but yeah, just to give you an idea. So these again, these are the parameters which I get trained. Let's say this is a hat. corresponding to what we got in logistic regression. This is a b hat, and these are the parameters that uh, it obtained from the by minimizing the error, right? Okay. So, uh, is there any other questions? So, yeah, someone has asked what is precision and recall. I'll just go into that. If you have any other questions, you can ask me right now. Okay. So, uh, what is the accuracy of our model, right? So, firstly, accuracy is number of true positives plus number of true negatives divided by total samples. Why true positive by plus true negatives? Because these are the samples. The true positives are the ones which you have, you know, which you have correctly uh, tagged. Whereas true negatives are also the ones which you have correctly tagged as negative. Whereas false positives and false negatives are the ones which you have incorrectly tagged. Right. So that's why this is the accuracy. So accuracy is basically the correctly tagged uh, set divided by the incorrectly tagged set. So you can directly calculate from this example, like what is the accuracy of the model. Like you can count the number of true positives, the number of true negatives, and find what is the uh, also the total sums. I think it's countable, right? It's not many, and you will count what is the accuracy. So can someone like count it and just tell me what is the value of accuracy in this? Okay, did anybody calculate what is the accuracy? 0.54, 54%, right? Okay. So what is the number of true positives? For accuracy, you need to know the number of true positives, right? Okay. What is the number of true negatives? I think 8, right? So true negatives is this region, right? So this region, like uh, the hollow circles in the light gray area. So these are not spam. The hollow circles are not spam, and they have truly classified as not spam. So I think there are 8 hollow circles in the not spam region. Right. What is the false positives? So false positives are spam. Uh, so if you see from this, so false positives are not spam but are classified as spam. So these are the in the red shaded areas. So I think there are 1, 2, 3, 4, 5, 6, 7, 7 points. And false negatives are the whose true class is positive but are predicted as negative. So these are the regions, the solid circles in the dark gray region. So 1, 2, 3, 4, 5, 5 points. Right. So from here you can calculate the accuracy as 6 plus 8, true positive plus true negative divided by total, which would be 6 plus 8 plus 7 plus 5 total. Right. Did anybody understand that? How much is it coming out? So 8 plus 6, 4 into 26. Yeah. How much is it in percentage? It's yeah, 53%, 0.53. Right. Okay. So now, I guess now you guys have understood what are true positives, true negatives, false positives, false negatives, and all those things. And okay, someone is asking, not able to join the class. How can I get the recording? Yeah. Uh, Someone has shared the YouTube link. Yes. Let me check if there are any questions on YouTube. Sorry? Yeah, about the exam, I'm not sure. Probably NPTEL will inform you. Maybe you can check the mail. Yeah, I'm not in charge of the exam. So, okay. Okay. So you have been looking at, the assignments, right? The assignments you have got, right? Yeah, so it will be on the, yeah, it will be same as the level of the assignments. Also, you guys must have got previous year's question paper. No? No? Okay, I will check, and from the next class, maybe I will, um, give you some questions based on the previous year's assignment, previous year's question paper, and yeah, assignment as well. So I think I saw the week one assignment. I think it's basically the basics. I think most of which I have covered, and probably I think in one of the questions they have asked to calculate what is precision and what is recall and those things. So I think assignments. I think you are good with the assignments, right? About the main exam, I will just let you know. Okay. Okay. Someone has asked, can you provide one more example of classification? Right. So, yeah, like as in, fraud detection, let's say. So you have, so there is a transaction on your bank account, let's say, and you want to determine whether that transaction is fraud or not. So the bank on its end runs a ML algorithm, and if it's a fraud, it will get tagged as one, and in that case, the bank will stop the transaction. And if it's a not a fraud, then it will be tagged as zero. In that case, the bank will let the transaction go through, right? So yeah, that is another example of classification, and yeah. Yeah, so quickly, we don't have much time. I'll just go into precision and recall. So someone has asked what is precision and recall. So this is basically the definition of precision and recall: true positive divided by true positive plus false positives. Okay. So if you see from here, so this is the true positives and divided by the total predicted positives. Recall is true positive divided by true positive plus false negatives. So in this column, so true positive divided by true positive plus false negatives. So this is the uh, you know uh, definition of precision and recall. And well, there is something called F1 score, which is twice precision into recall divided by precision plus recall. So why do we need these three things? Precision, recall, and F1 score, and all those things. Why do we need these things? So let's say you are predicting something. Let's say you are predicting whether a person has cancer or not. Let's say based on the symptoms. Now you don't want to miss out a person, right? You don't want to let's say if someone has cancer, he needs to be treated immediately, right? You cannot miss out. So you cannot afford to have you know false negatives. So that means truly he is positive, but you are categorizing him as a negative. So that person will not receive the treatment, and that will be a very bad thing that could happen. So in that case, you try to minimize your false negatives, right? You can, if someone is, or if someone is negative but is getting tagged as positive, then it's okay. He'll get the treatment, and assuming that the treatment is not very harmful to a non-cancerous person, it's okay if even if he gets the treatment, right? But you cannot afford to have false negatives. In that case, you are classifying him as negative, although he has cancer, and he will not get the treatment. So that will be very bad. So in that case, what you will do is you try to minimize false negatives, and to minimize false negatives. So if you see in the recall, formula, in the denominator you have false negatives. So if you minimize false negatives, your recall will be very high. So in that case, you will not look at accuracy. You will not look at how accurately you are predicting, cancer or not. In that case, you will try to maximize your recall. So accuracy is not always a good parameter. So the moral of this thing is that even if you are like, accurately predicting, let's say your accuracy is 90%, your accuracy of the model, but still you are, not capturing all the people who have cancer. That could be have negative effect on, those people. So in that case, you'll not look at accuracy, you'll look at recall. So do you understand? Like these formulas are okay. You can calculate recall, you can calculate what is the percentage and all those things. But do you understand the, why we need it? The physical reason behind it, and why it depends on, uh, the right, on the problem statement that you are dealing with, right? So you cannot just blindly, maximize accuracy or maximize recall and maximize precision, you know. So in that case, you have to like think about the problem statement, what you want to do, and proceed accordingly. Right? So, any questions on this? Let me see. No, precision and recall is not the same because in precision you have in the denominator true positive plus false positives, whereas in recall you have true positive plus false negatives. Okay, so they are not the same. Right. Someone has Pritham has given the formula. Precision is probability of actually positive given the positive result. Right. And recall is probability of correct classification as positive given it is actually positive. Yeah. Someone has raised a hand. Rana, please. Yeah. So you mean by the formula or by the physical significance? You mean? Okay. So by the formula, if you see, precision is true positive divided by all the predicted positive. Okay. So whatever you are correctly predicting as positive divided by what anything you are predicting as positive divided by the total positive. Right. So it is the probability that the algorithm is predicting actually as positive given a positive result, right? As Pritham has mentioned. So given that you getting your algorithm is predicting a positive result, what is the probability that uh, those people are actually positive? Whereas recall is, given that they are positive, they have cancer, what is the probability that you are correctly classifying them as having cancer? So do you understand the subtle difference? In one case, you are given that they are actually positive. Another case, you are given that you are predicting as positive. So that is the difference. Yeah, please. Any other questions? Yeah. So that is a good question. Like how to increase the accuracy. So in the machine learning algorithm, if you like simply minimize the error, it will increase the accuracy. So like we saw in linear regression, right? So we are just fitting different lines, and we're choosing the line which is minimizing the error. So minimizing error just means maximizing your accuracy, right? That's what you want. But as I said, precision recall has its own importance. Where in there will be cases like as I described as a patient having cancer, there will be cases when you don't want to look for accuracy. I mean, you might have a model which has very low accuracy, but it has a higher recall. That would give you a more social impact or more, that will help those cancerous patients. So always, maximizing accuracy is not the right way to go. Sometimes you have to maximize recall, and in other times you have to maximize precision. So I'll not tell like in which cases you have to maximize precision. You guys think about it, and I mean, as I said, in the case of cancer, you want to maximize recall, and you guys think about in which cases, in which practical cases you want to maximize precision. So I will not go into this graph. Maybe if someone has questions, we can discuss it later, but this is a graph where you choose how to you know which parameter to choose such that you get a balanced between precision and recall you know so yeah, this is a more advanced stuff, and maybe when we do logistic regression I can explain, or if someone has some questions we can talk about it. But yeah, so F1 score is something which balances precision and recall. So if you see, it is a product of precision and recall divided by precision plus recall. So if you have a higher F1 score, that means that neither your precision is too high, recall is too low, or and neither is the case that your recall is too high, precision is too low. So it achieves a balance between precision and recall. So there would be algorithms where you want to maximize your F1 score and find a balance between precision and recall, and whichever algorithm has a best F1 score, you will choose that as your best model. Right. So that could be case